Hello grade 10 students. Welcome to another virtual class. I am Miss Madhu Vadke. We are studying chapter 10, circles. Let's quickly recall the concepts that we have studied so far. A line that has one point common with the circle is called as a tangent, and a line that has 2 points in common with the circle is called as secant. There are 2 theorems in this chapter. According to the first theorem, a tangent is perpendicular to the radius at the point of contact, and according to the second theorem, from an external point, we can draw 2 tangents and length of these 2 tangents will be equal. In previous video class, we started with exercise 10.2 and we have solved few objective type of questions. In today's video lesson, we will continue with the same and apply these theorems in problem solving. Question number 4. Prove that the tangents drawn at the ends of a diameter of the circle are parallel. We have answered this part earlier in exercise 10.1 where we were asked how many tangents can be drawn parallel to a circle. These 2 parallel tangents will have point of contact at the ends of the diameter. So now in this question we are going to prove that the tangents that are drawn at the ends of the diameter are parallel. Draw a circle. Let's mark the center of the circle over here. Let's draw the diameter of this circle which passes through the center. Label the ends of the diameter as AB. So line XY and PQ are the 2 tangents that have point of contacts A and B respectively. Now OA is a line that joins the center to a point on the circle. So OA will be the radius. Similarly, OB will also be the radius, and we know that the diameter is 2 times radius. So this implies that this tangent is perpendicular to the radius by applying the first theorem. Similarly, we can say that OB is perpendicular to PQ using the first theorem. So we have shown angle XAB equal to angle ABQ, but these angles are alternate interior angles which are made between the lines XY and PQ, cut by transversal AB. So this implies that XY and PQ are parallel. What are we given in this question? A circle with center O, where AB is diameter, XY and PQ are tangents. We have to prove that XY is parallel to PQ. XY will be perpendicular to OA. So this implies angle XAP is equal to 90 degrees. Reason: radius perpendicular to tangent. Similarly, we can write PQ perpendicular to OB. So angle ABQ is equal to 90 degrees. Same reason, radius perpendicular to tangent. So this implies angle XAB is equal to angle ABX. But these angles are alternate interior angle. So this implies that XY and PQ are parallel lines. Question number 5. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. What are we given in this question? We have a tangent drawn to a circle. So let's draw a circle with center O and let XY be a tangent. touching the circle at point P. Let the center be O. We have to prove that the perpendicular at the point of contact to the tangent passes through the center. So let's consider a perpendicular to this tangent at point P which does not pass through the center. So let's say PQ is a line that is perpendicular to the tangent and does not pass through the center. Let's write down what is given. XY is a tangent to the circle with center O, and we are given that QP is perpendicular to this tangent XY. We have to prove that this perpendicular QP passes through the center. We are going to use the first theorem to prove this question. So we will have to do some construction, that is join point O, that is the center of the circle, to the point of contact. So OP is the radius of this circle. And now we can use the theorem that radius is perpendicular to the tangent. So OP will be perpendicular to XY, reason radius perpendicular to tangent at the point of contact. So this implies angle OPY is equal to 90 degrees. But we are given in the question that QP is perpendicular to the tangent. So this implies angle QPY is also 90 degrees. So we can say that angle OPY is same as angle QPY, and this is possible only if OP and PQ coincide. These two lines coincide. It implies PQ passes through the center. Question number 6. The length of a tangent from a point A at distance 5 centimeters from the center of the circle is 4 centimeters. Find the radius of the circle. Let's take point A over here. From this point, we have a tangent to the circle. And this point A is at a distance of 5 centimeters from the center. Let's mark the center as O and join the center to point A. So this distance of point A from the center is given as 5 centimeters. Let's mark the point of contact as P. So length of the tangent will be AP, which is given as 4 centimeters. Join the center to the point of contact, so OP will be the radius, which we have to find in this question. Now OP will be perpendicular to the tangent AP. This is using first theorem. So this implies triangle APO is a right angle triangle. And so we can use Pythagoras theorem. Now we have already studied in lower classes that 3, 4, 5 are Pythagorean triplets. So obviously the radius of the circle will be 3, and you can use Pythagoras theorem to find. Radius will be equal to 3 centimeters. I am writing this answer directly because 3, 4, 5 are well-known Pythagorean triplets. Question number 7. Two concentric circles are of radii 5 centimeters and 3 centimeters. Find the length of the chord of the larger circle which touches the smaller circle. What do we mean by concentric circles? two circles that have a common center but they have different radii. So let's draw these two circles. Let point O be the common center of these two concentric circles. We have to find the length of the chord of the larger circle which touches the smaller circle. So let's draw a chord to the bigger circle that is touching the smaller circle, say at point P. Let's label the chord as AB. While AB is a chord of the larger circle, it is a tangent to the smaller circle because it touches the circle at point P, which is the point of contact. Let's join the center to the point of contact. So we get OP as the radius of the smaller circle. If we join OA, we get the radius of the bigger circle. So in the figure, OA is R, which is radius of big circle, and OP is small r, which is radius of smaller circle. Using the first theorem, we can say that OP is perpendicular to AB, as radius is perpendicular to tangent at the point of contact. So this implies triangle AOP is right triangle. And we can then use Pythagoras theorem in this triangle to find AP. We are given the radius of bigger circle as 5 centimeters and the radius of smaller circle as 3 centimeters. So hypotenuse square, that is AO square, is equal to OP square plus AP square. Substituting these, we will get AP equal to 4 centimeters. I have skipped these steps over here to find AP because we know that 3, 4 and 5 are Pythagorean triplets. So we can directly write AP as 4 centimeters. Now we have AP equal to PB. Why? Recall in previous video class I had mentioned one theorem that we have studied in grade 9. That is, a line drawn from the center perpendicular to the chord bisects the chord. So OP is the line that is drawn from the center. It is perpendicular to the chord AB and therefore AP will be equal to PB. So if AP is 4 centimeters, then PB will also be 4 centimeters. So AB will be equal to 2 times AP, and that is equal to 8 centimeters. Question number 8. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. The word circumscribe means that a circle is drawn inside a quadrilateral such that it touches the sides of the quadrilateral. So here we have quadrilateral ABCD touching the circle at point P, Q, R and S. So we are given quadrilateral circumscribes a circle, and we have to prove that AB plus CD is equal to AD plus BC. To prove this equation, we are going to make use of the second theorem that we have studied in the chapter, which states that tangents drawn from an external point are equal in length. So from point A, we have a tangent AP and tangent AS to the same circle, So AP will be equal to AS. Similarly, from point B, we have two tangents BP and PQ. So BP will be equal to BQ. From point C, the tangents are RC and CQ, so they are going to be equal in length. And from point D, we have tangents DR and DS. So these two are going to be equal. But we have to write down these equal tangents in such a way that we are able to get this result. So keeping in mind we want AB and CD on one side of the equation, we are going to write down these equal tangents. So let's start with point A. AP is equal to AS. Now looking at the figure, if we add BP to AP, then I will get the side AB, which is this term of what we have to prove. So we must write PB on the same side as we have written AP. So BP is equal to BQ. Now we want CD. So CD is over here, which is sum of RC and RD. So we will write on the left hand side CR and on the right side CQ, because these two are the equal tangents. If we add DR to RC, then we get CD. So DR should come on the left side. And DR is equal to DS. Reason for all these can be written together. Length of tangents from an external point are equal. Now please do not write theorem 10.1 and 10.2. You have to write down the statement in your answer. And it has to be written only once, even if you are using it 4 times. Now we will add these equations. So on the left side we have AP plus BP plus CR plus DR. On the right side we have AS plus BQ plus CQ plus DS. Let's group the terms. AP plus BP and CR plus DR. On the right side we will add AS and DS. Then we will add BQ and CQ. From the figure, AP plus PB is AB. CR plus DR is DC. AS plus DS is AD. BQ plus CQ is BC. So we have shown that AB plus CD is equal to AD plus BC. With this we come to the end of this video lesson. Your assignment for today is example 2 of NCERT textbook. Two tangents TP and TQ are drawn to a circle with center O from an external point T. Prove that angle PTQ is equal to 2 times angle OPQ, which is marked over here. This is an easy question which involves application of both theorems that we have studied. Angle OPT will be 90 degrees. Why? Because OP is radius and TP is tangent, so they are going to be perpendicular using the first theorem. So if you mark angle OPQ as x, then this angle will be 90 minus x, and this angle will also be 90 minus x. Why? Because we know that TQ and TP are equal in length because they are tangents drawn from an external point to the same circle. This is second theorem. Now we can write angle T plus angle TPQ plus angle Q equal to 180 degrees using angle sum property of triangle TPQ. On solving that equation, you should get this result. I hope now it will be easy to solve this question. See you in the next class. Until then, goodbye.